What if I told you there are planets in our galaxy made of solid diamond? Imagine a world where, deep beneath its swirling clouds, it literally rains jewels. This sounds like something ripped from the pages of a sci-fi novel, a treasure hunter's wildest fantasy. For decades it was just that, a tantalizing theory, a cosmic what-if. But this isn't pure science fiction anymore. Scientists have just witnessed for the first time how these incredible worlds could form, and it's changing everything we thought we knew about the universe. The line between geological marvel and astronomical phenomenon is blurring like never before. We're not just talking about planets with a few diamonds. We're talking about a weather pattern where the sky opens up and releases a torrent of precious gems. Stay with me because we're about to journey into the heart of giant planets and witness the birth of diamond rain. A discovery made not by looking out into space, but by recreating a piece of an alien world right here on Earth. The cosmos is filled with worlds far stranger than we ever imagined. We've found planets where a year is only a few hours long, planets darker than coal, and planets where it rains molten iron. But the idea of a diamond planet, a world overflowing with riches, has always felt like a step too far. For years, astronomers pointed to a fascinating exoplanet called 55 Cancri E. It's a super-Earth, about 41 light-years away, and based on its size and mass, early theories suggested it could be a world made largely of carbon, compressed into diamond. This super-Earth is almost twice the width of our planet and has about 9 times the mass. But confirming how such a world could even exist remained one of the biggest challenges in planetary science. How do you study the weather on a planet trillions of miles away? How do you understand what's happening thousands of miles beneath its surface, under pressures and temperatures so extreme they're almost impossible to comprehend? The answer, it turns out, wasn't to look deeper into space, but to look closer at home, inside some of the most advanced laboratories ever built. To solve the mystery of diamond rain, scientists had to get creative. They couldn't send a probe to Uranus or Neptune. The intense pressures and temperatures would crush and vaporize any machine we could build. So, they did the next best thing. They brought the heart of an ice giant to Earth. In a series of groundbreaking experiments, an international team, including scientists at the SLAC National Accelerator Laboratory, set out to replicate the conditions found deep inside these distant worlds. Their target wasn't an actual piece of a planet, but a tiny piece of plastic. They used polystyrene, a common plastic made from hydrogen and carbon, which serves as a perfect stand-in for the methane that gives planets like Neptune their beautiful blue hue. Methane is just a simple molecule of carbon and hydrogen, the basic building blocks for diamonds. The idea was straightforward. If you squeeze and heat this material enough, the carbon and hydrogen atoms should split apart, and the carbon should then bond together to form solid diamonds. To do this, they needed 2 things: unimaginable pressure and a way to see what was happening on an atomic level in real time. For the pressure, they used a device that sounds as powerful as it is, a diamond anvil cell. This incredible tool is like a miniature vice that uses 2 perfectly cut diamonds to squeeze a sample with immense force. Then they blasted the sample with a high-powered optical laser, creating shock waves that ripped through the plastic. This process generated temperatures over 2,200 degrees Celsius and pressures millions of times greater than Earth's atmosphere, perfectly mimicking the environment deep inside an ice giant. But here's where the true genius of the experiment comes in. As they bombarded the sample, they fired the world's most powerful X-ray laser, the Linic Coherent Light Source, or LCLS, at it. This laser fires pulses that are unbelievably short, just 50 femtoseconds long. That's so fast it can take snapshots of atoms as they react and form new structures. It's like having a camera with a shutter speed so extreme you can watch chemical bonds break and reform. For the first time ever, they weren't just guessing that diamonds were forming. They were watching it happen. The results were stunningly clear. They witnessed a huge portion of the carbon atoms in the plastic get squeezed into tiny diamond structures, just a few nanometers wide. The hypothesis was no longer just a theory. It was now a process observed in a lab, providing the strongest evidence yet that diamond rain could be real. With this experimental evidence in hand, the picture of what's happening inside our solar system's own ice giants, Uranus and Neptune, came into much sharper focus. These planets aren't solid balls of rock like Earth. Beneath their thick atmospheres of hydrogen and helium, there's a vast, slushy mantle made of water, ammonia, and methane ices. Thousands of miles below the surface, the conditions are just right. The immense pressure and intense heat of the planet's interior act like a cosmic factory. Here's how it likely works. The high pressure squeezes the methane molecules so hard that they break apart, separating the hydrogen and carbon atoms. Freed from their hydrogen bonds, the carbon atoms find each other in the chaos. They begin to link up, forming the strong, stable crystal lattice of a diamond. Inside a planet over thousands of years, these diamonds could grow to be enormous, potentially weighing millions of carats. Once formed, these solid diamonds are denser than the surrounding icy slush, so they begin to sink. This is the diamond rain, a slow, steady, glittering shower falling through the planetary mantle, pulled down by gravity. Over billions of years, this process could have created a thick, solid layer of diamonds surrounding the planet's core. It's an almost unimaginable image. A layer of diamond, perhaps miles thick, buried deep inside these beautiful blue worlds. What makes this even more exciting is a very recent update from these experiments. By studying the process over longer timescales, scientists revealed something that changes the game. Diamond formation happens at even lower pressures and temperatures than previously thought. This is a huge deal. It means diamond rain doesn't just start in the deepest, most extreme parts of the planet. It can begin forming at much shallower depths. This discovery widens the diamond rain zone, suggesting the phenomenon is more widespread and has a bigger impact on the planet's structure than we ever realized. So why does it matter if it rains diamonds inside a planet billions of miles away? Because this single phenomenon could solve some of the biggest puzzles about Uranus and Neptune, and even about countless other planets scattered across our galaxy. First, it could explain their bizarre magnetic fields. The magnetic fields of Uranus and Neptune are strange. Unlike Earth's, which is neatly aligned with our planet's rotation, their fields are lopsided and off-center, as if they're generated by some strange, swirling source. For years, scientists struggled to explain why. Diamond rain provides a compelling answer. As these solid diamonds sink, they could drag the surrounding gas and ice down with them, stirring up the planet's interior. The new research suggests these diamonds fall into a layer of supersonic water, a strange electrically conductive phase of water. The churning of this conductive layer by the falling diamonds would create powerful electrical currents, acting like a dynamo and generating the planet's weird magnetic fields. This exotic rain isn't just a curiosity. It could be a fundamental engine shaping the entire planet. And it doesn't stop there. The sinking of these dense diamonds could also be an internal heat source. As they fall, friction and compression would release energy, contributing to the planet's internal temperature and influencing its evolution over billions of years. But the implications reach far beyond our own solar system. The new research showing that diamonds can form at lower pressures means this process isn't limited to massive ice giants like Uranus and Neptune. It could also be happening on mini-Neptunes. These are smaller gas planets, more massive than Earth but less so than Neptune, and they are one of the most common types of exoplanets we've found in the galaxy. This means thousands, perhaps even billions of planets across the cosmos could be experiencing diamond rain right now. Understanding this process is crucial as we search for habitable planets, because it helps us model the interiors, atmospheres, and magnetic fields of these distant worlds. We started with a concept that felt like fantasy, worlds where it rains diamonds. But through brilliant experimentation and relentless curiosity, we've taken a giant leap from fantasy toward reality. We now have powerful evidence that deep within the serene blue atmospheres of ice giants, an incredible alchemy is taking place, turning simple molecules into a downpour of jewels. This isn't just about finding treasure in the sky. It's about understanding the fundamental physics that govern how planets form and evolve. This discovery shows how a single bizarre weather pattern can influence a planet's internal heat, shape its magnetic field, and redefine what we thought was possible. From early candidates like 55 Cancri E, once hypothesized to be a diamond world and now thought to have a dynamic volcanic atmosphere, to the icy depths of our own neighbors, we are learning that the variety of worlds out there is far greater than we ever dared to imagine. The evidence is building that diamond worlds aren't just possible, but could be a fascinating part of the cosmic landscape. It leaves us to wonder, what other unbelievable phenomena are just waiting to be discovered, hidden in the hearts of the countless planets that glitter across the night sky? This single discovery is unlocking so many other mysteries of the cosmos, If you found this as mind-blowing as I did, and you want to keep exploring the most incredible secrets of our universe, make sure you subscribe and hit that notification bell so you don't miss our next journey into the unknown.